Hello, keen beans and homework heroes. Thank you so much for tuning in to this week's concept video. We're getting around the next stage of our measurement game. You've done a lot of area, which is excellent, which is the meters squared or the centimeters squared, timesing length by width or base by width. We're now delving into this learning. We are learning to understand the difference between volume and capacity and how to measure them. The capacity side of things is one that I struggle with a little bit as well, but I want to just explain capacity. But what I'm going to do in this video is more about the volume. The reasons for that will become clear in this video. All right, well, let's talk about capacity versus volume. I've got this wicked little poster here to understand a little bit more about it from TeachStarter, which is a nice little website that we use for resources. You can see there that there's two posters, and it's got a TeachStarter thing in the middle, but hopefully you can understand what is going on. It says here, capacity is the amount of liquid a container can hold. We measure capacity of anything which can hold something else. So a lot of liquid containers will have a capacity or potential capacity, and maybe your stationary holders as well will have a capacity because they can actually hold something. If an object is not hollow, it doesn't have a capacity. For example, a dictionary isn't hollow, therefore it doesn't have a capacity. Anything that can hold something, a container, will have a capacity. It's usually measured in litres or milliliters, because usually you're referring to a liquid or a gas that can be filled in a container. When we go on to volume, and this is something we'll work on, it's more about the amount of space an object takes up. They've given us a great example to understand this, because as this balloon is blown up, the volume increases because the amount of space that the balloon is taking up increases. You're increasing the volume of gas in a balloon, for example. Another little poster just to understand as well is this one just here. We've already done area, so you know number of square units in a closed figure. A volume, of course, is the amount of space that a three-dimensional object, so it refers to 3D objects, takes up. And capacity is that ability to hold something. So you can see here that the amount of cubes in this, there's 3 layers. So a volume will include all of those layers, all of those dimensions. But the capacity is the ability of an object to hold something. So the ability of an object to hold a liquid or a gas. Again, with regard to capacity, we'll do a little bit more in the week. But today I just wanted to focus on volume and show you where we're at. All right. So volume is the 3D shape scenario. We're going away from the area, the 2D, and into the 3. And you can see here that volume is a combination of 3 measurements. It's a combination of length, it's a combination of width, and it's a combination of height now. Because we're into 3D, the shapes will always have a height as well. When you combine those 3 together, you will have a cube scenario because you're actually timesing 3 different things together. So centimeters cubed or meters cubed or even millimeters cubed if you're going for a really small object. Your stationary holders, I'd presume, will be measured in centimeters cubed because we've got 3 different centimeter measurements. But a building, for example, might be meters cubed because you might have a really tall building that's large in meters and you're measuring it in meters cubed. So with that being said, it works the same as area, but we're just multiplying 3 different measurements rather than 2. So I've got a great little couple of questions here, and we'll do these ones first. So let me zoom in on this one and see how we go. So we've got 2 different objects here, both with different volume to work out. I'm going to do the first one. I'll do the second one as well, but you can pause the video to see if you can work it out before me. So this one, we're looking at the 3 different dimensions. We've got a 5 centimeter length. We've got a 5 centimeter width, 6 centimeter length, and a 3 centimeter height. We already know that volume is length times width times height. So for this one, we're going to do 6, and you can assume that I would put centimeters, but in terms of writing it, I'm just going to put the dimensions, the numbers, 6 times 5 times 3. But the answer, I'll definitely put the centimeters in as well. All right. no need to get BIDMAS into play because multiplication is left to right. 6 times 5 is 30, and 30 times by 3, well, we've got 30, 60, 90. So the volume of this shape, this rectangular prism, is 90 centimeters cubed. Really great stuff. 90 centimeters cubed will be the volume of this shape right here. And I'll put it in yellow so you know it's the yellow measurement. Alrighty, it's your turn to try and measure this volume here. Pause the video and I'll go through the answer in a moment. Hopefully you've paused. I'm going to go through it now and hopefully you got this absolutely spot on. Very similar scenario here, but this time the width is 6, the length is 5, and the height is 4. So we're going to do the width after the length. The length is 5. The width is 6, so that's the same sort of start as we had before, and the height is 4. All right, so hopefully that's the equation you worked out as well. But this time we're going to do 5 times 6, which is 30, and then 30 multiplied by 4. Well, I could do 3 times 4, which is 12, and then just whack that 0 on at the end, because technically speaking, it's 30 times 4. So my answer here would be 120, and I hope in your answer you put centimeters cubed. Once again, the reason why it's cubed is that we are timesing centimeter by itself and by itself again. So we're timesing centimeter 3 times. When it's area, you're timesing centimeter by centimeter, so it's squared. But now we're timesing centimeter by centimeter by centimeter, so now it is cubed. All right, time for your question. And when I say video answer next door, this is the one you're looking at. You've got another rectangular prism here, and you can see the length and the width and the height. Your job is just to tell me in meters cubed. Whoa, don't leave that out. And if you can't do a little 3, just do a big 3 next to the M. What the volume of this rectangular prism is. So once again, what is the volume of this rectangular prism? Meters cubed in your answer, and then you can answer the other 2 questions. And hopefully you can get Silent Discoing on Monday. Thanks and have a lovely weekend.